So this is my 20-gallon tank for my pulsar reactor. It's empty right now. I'm still working on a valve system so I can take the water in and out very fast without having to reach in there. See, this is going to be lined with solar panels, and my limelight reactor star is in the middle, okay? The catalyst gets hit with the star, and all this is crushed underwater. I put weights on top and it holds all this down underwater. I'll show that at another time. It's a little difficult to get the water out of a 20-gallon tank. This thing weighs 500 pounds when it's full. It's amazing how heavy water can be. But if you come over here to one of my other reactors, let's say you wanted to take the water out of one of these. Let's say you wanted to dump the water. The one on the right, I've been using it for electrolysis, okay? I've had water out of the lake out back in here and a lot of other things. I've been trying a lot of different experiments. So you'll notice it's real easy to get the water out of here. Just one valve. Let me show you. Okay. So it's very easy to let the water out of one of these reactors. I designed it that way on purpose, where you have just one valve, okay? One valve and you can change your electrolyte. You fill it through the top. It's filled through the top. But it's very easy to dump one of these out. Oh, sorry, I dropped my flash torch. There you go. Nothing to it. Give you an idea how easy it is to change the water in one of these things. So design is everything, okay? You design something, you want to make sure you design it properly, okay? These are some of the most powerful oxyhydrogen fuel cell reactors you're ever going to see. They're the genius design too. One valve, okay? Easy to get the water out. That's it right there, guys. The most advanced oxyhydrogen water fuel cell reactor on the planet. When it comes to water fuel cell technology, nothing was left out here. As you can see on the bottom here, we have the gas import that goes in and the gas comes out. It goes in right here and comes out right here. The riser goes up through the middle. Okay? This visual port on the bottom, you can see the hose inside. I'm going to give you a breakdown of this reactor soon. Here's the top. You can see the blast chamber. Yeah, that's full of stainless steel scrubbers. That's how I managed to do that. That's the blast chamber. That keeps your flashbacks nice and quiet. If you look in the top here, that's where you fill it. Okay, you put your finger right here and you fill around it and you fill up this whole reactor with water. Right now I'm using this reactor as a bubbler. See, they work both ways. You can use it as a bubbler, you can use it as a scrubber, and I can use it to produce oxyhydrogen gas if I want to. My electronics are right here. It's very simple. This is hooked up to a fuel cell array down here. It's a 7-plate array. Right now I just have it hooked up to the light. You can hook a pulse width modulator up to this. And you can hook any power source you want up to this reactor. Doesn't matter if it's wind, solar, anything you want to hook up to it. See, the bubbler, the fuel cell, the reactor, the flash port, everything all in one. You ever seen anything like that in your life? Probably not. This is what makes it all possible right here. At any one time, the water is about right here in this reactor. And this entire area up here is full of stainless steel scrubbers. Okay? And that's how I stop the flashback. So you don't get a loud report. And you'll notice that a lot of bubblers online won't have this. It's all significant to my technology. You're only going to see that here. A reactor that does everything. All in one. Yeah, normally you can operate this reactor with no tools. You can turn all this with your hand. It's got thread tape on here and magic lube. Okay? There's no tools required. But just in case it gets a little tight, you know, 3-inch, this is all 3 and 4-inch. So it's a little hard to get your hands around. All you need is an oil filter wrench. Very easy to get. You just have this little strap, and you put it around here and you can turn it. And that's how I access all my reactor cores. Okay? So you need an oil wrench. You can get inside these things real easy. Okay? So remember, where you put these ports has a lot to do with how you designed your reactor. You see, I have this port right here. It makes it easy for me to dump the water, but it also makes it easier for me to hook up other gases. Let's say I wanted to hook propane up and run it through the reactor while the electrolysis cycle is running. I could have hydroxypane or mixed butane. So you can add gases to the reactor like this. So you got to be smart where you put your valves. All my reactors work this way. Okay? Simple one valve. It's the best way to control HHO2. You have to shut it off immediately for your flashbacks. You don't need no flash arresters with these type of reactors because that's what the top does. Okay? And you guys know the flash port. A lot of you advanced guys out there know how a flash port works. I mean, I'll make a whole nother video of that to cover it. I'm just giving you guys an idea, okay, of how these things work, how they run. What's on the top? What is this? You know, it's a resistor. It slows down the speed of the gas. This is where I capture all my flashbacks. And it's silent. It's completely silent. It just goes click and that's it. Okay? So when you design a reactor, a hydrogen fuel cell, you know, intelligent design is everything. Design is everything. Okay? Anytime you build something, you want to think ahead. You know, are my tubes big enough? Or do I have enough room to put things inside? Is my light going to fit? Can I see the gas? You know, notice how visual these reactors are. Is my reactor safe? You know, build them out of PVC. Is it easy to build? Yes. Like I said, you have to think of all these things when you're building and designing anything oxyhydrogen fuel cells. Okay. Easy to access, easy to work on, easy to replace, easy to build. Design is everything. I can't stress that enough, guys. So when using this oxyhydrogen wet cell reactor core in the bubbler stage, this becomes a very important part of any HHO gas system. Okay? You're going to need your flash port. You're going to need your blast chamber or some type of resistance. You have your riser tower. It's very visual so you can see. And you have your valves, the in and the out. Okay? So in this mode, I'm using the reactor as a safety device as it prevents the flashback from reaching the next reactor next to it. Now, let's say I have this one running in oxyhydrogen fuel cell generation mode and I'm making gas. I have a power supply hooked up. Okay? In that mode, with an electrolyte inside the reactor, a power supply connected, you want to make sure any flashback that enters here rises up through this and stops right here. It can't go back down through this water column, okay, and come out here. It's impossible, okay? The way this was designed, the gas goes in the bottom, okay, rides up a tube all the way through the middle to the top, okay? So it ignites the gas here. And then the flash is stopped right there. Okay? So all you have to do in this mode is just add distilled water. It's in safety mode. This is like bubbler, scrubber, safety flash arrestor mode. All you have to do is fill the reactor core with distilled water. And if I want, I can add electrolyte to this and start producing gas. And then I've turned it back into an oxyhydrogen fuel cell reactor again, like the one next to it. And they can be connected together in series, or in even parallel series if you want. There's no limit to how much gas you can make or what volume. So I hope this gives you a little bit of a description of one of the wet fuel cell reactors that I've got here on the table. Okay? You gotta remember, these things are, I'm gonna go through as many pictures as I can really quick to show you guys here. You gotta remember, these things are beautiful, they're compact, they're really lightweight, they're powerful, and they're capable of providing an endless amount of oxyhydrogen gas. Okay? A wet cell reactor has many advantages over a dry cell. Many advantages. You can fill these things up with swamp water. Water right out of the canal with grass in it, dirt and sand. Dump it right back out and wash it out again. You can't really do that with a dry cell. So they're very convenient. Okay? The wet cell reactor core has many advantages over a dry cell. I'm just going to go through these pictures really quick for you builders out there. I'm sorry I didn't have a lot of time to explain it in this video, but we'll go over it again. Okay? And you got to remember, all this stuff is fully compatible with your dry cells. You can just get a reservoir and hook it up next to this stuff. It all works together. All HHO technologies work together. Okay? I'm just going to go through here, show you some of my clean connections, you know, power supplies. You know, I guess a picture's worth 1,000 words, so I'm just going to go through here really quick to end this video. Flash ports, quenching technology, my hose, torches, wands. That's the plasma core attachments right here. We'll go over that in another video. You get an idea how all that works and how it was built. So I'm just going to go through these pictures really quick to end this video. So I hope this helps some of you builders out there. You can just go back and pause it. There's a lot of my laboratory equipment, stuff I work with. You know, there's my Stirling engine, pulse width modulators, power supplies. Okay. Here's my exciter array. That's what's in the bottom here. It's very similar to the King of Random setup. That's what's in the bottom here, and then I just have all this on the top. So a lot of you guys out there already know how a lot of this works. Clean connections, you know, the hose that goes up through the middle. You know, you can make your blast chamber any size you want on the top. You know, you can adjust these to any size. You know, you can make it smaller, make it taller. Do what you got to do to make it work to fit your system. Okay, there's where I get my lights. There's connections. So just some brief pictures for you builders out there. You can go back through and pause it. There's the 3-inch clear PVC. You can't do it without this. If you notice, when I make 3-inch, all these connections, I use a very powerful JB weld. Okay, it's for PVC. Anytime you're working with 3 or 4-inch and you make a connection, you can't just put PVC glue on here. You got to use a little JB weld on them edges. So when you put these things together, they're solid. They're very solid. Okay, it's reinforced epoxy. So everything I build here, it's very, you know, it's built very tight. Okay, any of these threaded areas have thread tape, magic lube. When I built this, you have to sand all that off because it gets all on the edges. Everything's been sanded really nice and built that way. Okay, so when it comes to sealing up your reactors, you got to have a really good sealant. Not only do you use PVC glue, but you can add J&B weld. Okay, it makes a very solid weld. You don't want to build it and then have a leak. And if you ever do build one of these reactors and have a leak, you can patch it with some JB weld. If you have one little drip of water after you build this entire thing, JB weld is like steel. And once you patch it, it's never going to leak again. So I hope this helps you guys in your building of your oxyhydrogen water fuel cell. Okay?